Loan amortization is part of time value of money. We want to set up a series. So to amortize a loan is to set up a plan of periodic payments that will offset a loan. So we use what is called the present value annuity factor. And the formula for loan amortization is given by the amount of loan is equal to the periodic payment in the present value of an annuity. Of course, considering the compoundings. So we are given a loan, amount of loan is 1,000 baht. And this loan is to be paid in 3 equal installments or in 3 equal years. And we are told that the interest rate is 10%. At A, we are asked to calculate the payment, periodic payment, how much must we be paying every year. But B, we are asked to calculate or to set up an amortization schedule. So with the parameters given, we're going to say amount of loan is equal to periodic payment, present value, annuity factor, which is given by 1 minus 1 plus r to the power negative n over r. So our amount of loan is 1,000. The periodic payment is what we're looking for. So here we have 1. Our interest rate is 10%. And time is 3 over the rate of 10%. Now this also use the annuity table. When you clearly do it properly, what do we get on the other side? We get 2.487. Or better still, we can check the present value interest annuity table at 10%, 3. We check on the financial tables, you get the same figure. Let's try to check. So annuity, present value annuity here, we go under 10%, under 3. We get 2.487 or 869. That is a present value annuity factor. So when you divide this on both sides, what are we getting? What are we getting? Our payment becomes 402. This is our periodic payment. So to set up an amortization schedule or table, we have the following columns. Number 1, we have the balance, beginning balance. Number 2, we have the payment. Number 3, we have the interest. Number 4, we have the repayment, the loan repaid. Number 5, we have the closing balance. So our loan initially was 1,000. Periodic payment is 402 for the 3 years, 402 and 402. This column 1, column 2, column 3, column 4, column 5. So our interest is 10%. So column 1 times 10%. That is how we get column 3. So 10% of column 1 is 100. Column 4, we subtract column 2 minus column 3. So 402 minus 100, 302. And for column 5, subtract column 1 minus column 4. So 1,000 minus 302 gets 698. Then column 1 is column 5 brought down. So this is what we start with, 698. 10% of this, 69.8. And when you subtract 402 minus 69.8, what are you getting? What are you getting? $332.2. Then you subtract 169 minus 332.2. What are you getting? That's 698. You subtract 332.2. You get 365.8. This is our opening balance, 365.8. 10% will be 36.58. And you subtract this, you get 365.8 approximately. So when you subtract 365.8 minus 365, meaning the loan, this is what we call loan amortization. So we have completely repaid the loan. Any questions this far?
No.
Very clear? And we
Yes,
got
I'm
to cost of capital. So cost of capital has an interesting part where we call it work. Work is simply the weighted average cost of capital, or given the weight of equity times this cost, weight of preferred stock times this cost. And we are also given the weight of debt and the cost of debt. Then we have 1 minus tax. Okay, so we would be given what? Component. For instance, for equity itself, let's see, you would be told that the risk-free rate is 8%, and the beta 7%. Let's say beta is 0.6. Then expected market return, and we have 16%. We are asked to calculate the cost of equity. So you need to understand that equity is calculated using two formulas. There's what we call the Kaplan model, which is given by cost of equity is equal to risk-free rate plus beta expected market return minus risk-free rate. Our risk-free rate is 8% here. Our beta is 0.6. Our expected market return is 16% minus 8%, 0.08. So here we get 8% plus 0.6 times 8% here. So what we get? 4.2%. And we're told also that preferred stock has a dividend paid of 11.7%, quart, and the selling price of stock was 100 quart. So the cost of preferred stock is given by the dividend paid over the price of the preferred stock. We have 11.7 over 100 times 100. So we get a percentage of 11.7%. And further on, we are told that you have 10% interest on loan, and the tax has been given as 40%. So the cost of debt after tax becomes 10%. We remove the tax shield, 1 minus 40% of 0.4. This is giving us 6%. Then further on, you'll be given book values. Say, suppose we have a structure of capital that has loans that are as follows. Debt maybe 1,000. The preferred stock maybe 3,000. And the common stock maybe 7,000. In that case, you need to calculate the proportions or the amounts. The total here we have is 10,000. What is the weight of debt? 1,000 over 10,000, we get 0.1. 3,000 over 10,000, we get 0.3. 7,000 over 10,000, we get 0.7. So this is the weight. Now work therefore becomes, as the formula was given, the weight of equity, the cost of equity, weight of preferred stock, cost of preferred stock, weight of debt, cost of what? Debt. So what is the weight of common stock? 0.7. And that was the cost. We use the capital model, we got 12.2%. So here you put 12.2%. Plus the weight of preferred stock, 0.3. And the cost was 11.7%. Finally, cost of debt, we found as the weight of debt was 0.1%, 0.1, and the tax shield is already taken care of. So you directly get the cost, which is 6%. So when you multiply this by that, this times that, and this times that, the total what you get is your work. This is the weighted cost of capital. So you multiply 0.7 times 12.2 plus 0.3 times 11.7 plus 0.1 times 6%. Are you getting?
12.65.
12.65. This is called our weighted cost of capital. Now, sometimes you may not be given the aspect of debt. You may be told that the company has just declared a dividend of E1 in part. And the selling price is 20 kwacha. And the growth rate is 6%. We also told that preferred stock just paid a dividend of 20 kwacha. And the price of a dividend is 40 kwacha. And we are told the debt to equity ratio. Maybe we're not given preferred stock. We're actually told that debentures have 10% interest, and the tax, corporation tax, 30%. In this case, we were told that the debt to equity ratio is 0.5. In this case, we're going to use what is called Gordon's method to evaluate equity. So using Gordon's method, equity is given by P1 over P0 as cost. So D1 is got 10 over 20 as 6%. So this is 50%, half or 6%. We get 56%. That's the cost of equity. The cost of debt, we know after tax is what? Pay 1 minus tax. So we have 10%, then 1 minus 0.3. So instead of paying a debt of 10%, 7%. And debt to equity ratio has been given as 50%, meaning the weight of debt is 0.5. The weight of equity is 0.5. So in this case, you're going to find our work based on two components: weight of equity, cost of equity, weight of debt, cost of debt. So here, what is our weight of equity? 0.5. Its associated cost is 6%. To ensure that one is in decimal, one is in percentage, so to just be direct. The weight of debt is 0.5. Cost of debt 7%. So what do we get as our work? We get as our work
31.5.
8% plus 3.5%, which is 31.5, right? So this
Yes.
is our work. That is how we find the weighted cost of capital. Then we go to risk and return. Risk and return will be given the probability of assets A and B. 0.2, 0.3, 0.5. They're given this is what? 100 quarter, 200 negative, and 300, 200, 500, 400. We've been asked to calculate the expected return for each asset A and B. So we'll start with asset A. The probability of the return on A. So 0.2 times 100, 0.3 times negative 200, negative 6. 3.5 times 300, get 150. So when we add up, get this is expected return for asset A. We do the same for asset B. Multiply 0.2 times 200, what we get? 40. 0.3 times negative 100, get negative what? 30. 0.5 times 400,
200.
so what we get is 210. This is expected return for asset B. Then we also be asked to calculate the standard deviation for each asset. So we're going to now calculate the return for asset A as expected return for asset A. So here we have what? Probability and return for asset A as expected return for asset A, we square it. Then here we have return for asset B, return asset B, and find the variance, multiply the probability and return for asset B, and as expected return asset B, and we square it. So let's do the return asset A minus 110. How do we get? 100 minus 110, negative 10. So negative 10, we square it, which is 100. The probability 0.2, get 20. Then here we get 200 minus 110, we get 310, negative. Then square 310, multiply by 0.3. What do you get? 310, square it, get 9600 times the probability of 0.3. What we get? 28,830, right? Is that what you get? Confirm the calculation. 310 squared, we get 96,100 times 0.3, 328,830. Then here 300 minus 210 is 90. So 90 squared. So I get me 90 times 90.
8,100.
100 times
Yes.
5. You get 40, 50. So we add all this for the variance.
Sorry, sir, I have a question. Why were we subtracting from 210 to 590?
was an error. We're supposed to subtract 110. 100
Oh,
minus
okay.
110, 10. 200 minus 110 is minus 310. 300 minus 110 is 90. Yeah. And square it times 0.5, we get 4050. Let's add all this. 20 plus 28, 830 plus 40, 50. What are you getting?
32,900.
Get 32,900. The square root of 32,900.
181.3835.
181.385.
8. Yes.
And we divide, get the coefficient of variation. We divide standard deviation over the expected return. What are we getting? So we divide this one by 110.
1.648. Or let me just round it off. 1.6.49.
Okay. So we'll do the same for asset B. The return minus 210 is what? Negative 10 squared times 0.2, we get 20. Negative 100 minus 210, what do we get? Negative 310. 310 squared times 0.2, 0.3, we get 28, 830. We have 400 minus 210, what do we get? 190. So 190 squared times 0.5, what are you getting? 190 squared times 0.5, what do we get? 18. What are we getting?
That's
18, 050. Right? When we add all these, what are you getting?
46,900.
46,900. Square root it to get the standard deviation.
216.56.
216.56. Divide by expected return.
1.03.
So which one has more risk? Asset B. The higher the CV, the higher the risk. So this one has a higher risk. Then to calculate the covariance, we multiply column 1, column 2, column 3 together. So 0.2 times 10 times 10. What do we get here?
0.2.
So column 1, column 2, and column 3. Then let's go here. 0.3 times 310 times 310. What are we getting? 28, 8, 30, 20 times 28, 830 times 0.5 times 90 times 190. What are you getting? What are you getting?
8,550.
1,550. Multiply that, you get the covariance of A and B. What is our covariance? And multiply all these three.
The amount is too huge.
Yes, it's huge. It's okay.
Let's see, 4 billion 929 929 930 and 000 and
9,
4.
30.
Mm.
9 to 9, then 9 what?
4 billion, then 929 930
And 30.
and 3 zeros.
So they're positively related. And you find the correlation. You divide the what? Covariance over the standard deviation for A times the standard deviation for B. So the 4 billion 929 930 divided by what? Standard deviation for A was 181.3835 times standard deviation for B at 6.56. So what do you get?
Point 3. Uh, 1.5506.
So 125.
506.070.
So it's also positively correlated. Then they ask you to find, suppose the weight for each investment was 0.5. Weight of A, you invested 50%, and weight of B, you invested 50%. Then they ask you to calculate the portfolio expected returns. The portfolio expected return is weight of A and expected return of A plus weight of B and expected rate of B. 50% of A and 50% of B times the respective expected returns we found. These are 110 and 210. What are you getting? 110 and 210. 5 plus 105 to give you what? 160. This is the portfolio expected return. And they also ask you to find the portfolio standard deviation. First find the variance, which is what? Formula weight A squared times variance plus weight B squared times variance plus what? 2 for variance AB what's the formula? Continue. We're doing this yesterday. Then what's the formula?
No. Yeah. No.
You remember?
No, I can't remember.
Times 2 WA weight of A weight of B, then for variance of what? AB. Our weight of A is 0.5 and the variance of A was what? 32,900. Don't forget because we're getting the variance plus 0.5 variance of B 46,900 plus 2 0.5.
Sorry, sir. I feel like we made a mistake in column 2.
Column 2.
Yes, isn't it supposed to be also 190? Because you said 300 minus 110.
This is 400. Yes, 300 minus what?
110.
Yes, it's supposed to be 190. Yeah. Okay. Anyway, let's get the principle there. Then the covariance of AB is supposed to be what? Covariance of AB we found 4,929,930 times 4,929,930. So the answer that you get is called the portfolio what? Variance. Then when you square root it, the answer we get is what? The standard deviation, portfolio standard deviation. So this is basically what you're supposed to do on risk and return.